Hello, I am Tevfik Eftel Olcay. As a Göktürk team, we will present our project, development and testing of AI-based model for ship detection and classification in coastal zone surveillance. Here you can see our contents. Our team has 5 members. Me and Özlem worked on AI model and GUI design. Ali, Furkan, and Arda focused on the flight and hardware system. Also, we work together for communication system. Traditional ship tracking is slow and manual. Also, satellite data is not always reliable due to cloud cover, you can see, or delay. So we need a faster and smarter system. That's why we proposed an AI-based detection system that combines drone footage with deep learning. Here you can see our object detection algorithm architecture, and our architecture classifies ships private or commercial using our model. These results are displayed through an interactive customizable GUI. Functional requirements, achieving MAP 50 score greater than 0.85. Also, it should support multiple input types and provide night mode visibility enhancement. Also, ensure real-time processing with user-friendly GUI. There are some block diagrams. Drone camera data comes to Raspberry Pi and transmitted to ground station using Wi-Fi UDP protocol. Also, our AI detection model, input selection, and model is night mode active or not. Also, detection mode selection and GUI display. Thank you.
I'm Özlem and I will continue with implementation of our project. First, we have gathered our dataset from open source resources and general dictate of mapping. And for the AI model, we have used YOLO V8 medium model, and we also did hyperparameter optimization using Optimum library. After that, we have fine-tuned our model using 300 and more images to achieve domain adaptation, and we also integrated SAHI interface into our model. Here on the left, you can see an hyperparameter importance graph that we have obtained from Optuna. We have evaluated many graphs such as this one and did many trials to pick the best hyperparameters for our model. And on the right, you can see an example on how SAHI model works. It takes smaller pieces of each image and this way does better image detection on small images such as small yachts. And for the graphical user interface, we have built it using PySide 6, and we have different input modes. We have choosing model option and adjusting confidence threshold option. We can also see the heat map on our interface, and we can use different theme options such as this one, high contrast theme, and we can draw a region of interest and also do byte tracking. And we have also integrated night mode into our project. It enhances visibility and achieves better object detection in low light conditions.
Hi, I'm Ali, and I'll continue with detailed design overview. To this part, we can see the flight control algorithm and PID algorithms flowchart here. The functional requirement, our drone needs to have a stable operation with the flight time of 15 minutes and operable by remote controller. So the implementation of our project, we used ESP32 embedded software implementation with object-oriented programming-based code structure, and we also used platformer environment. When it comes to the IMU filtering techniques, we used complementary filter, Kalman filter, and notch and EMA filter to reduce vibration and motor noises. We can see the chart here, the filtered IMU values. To PID control algorithm, we use separate PID loops for roll and pitch values, which includes the anti-wind-up control and stabilizes the drone. At the end, we switch to the flight controller to have a better flight and meet the requirement. Thanks to the flight controller, we have faster, reliable, and more functional flights. But important note here, IMU filtering and PID coefficient techniques are still being used in this project with the flight control implementation.
Hello, my name is Arda, and let's continue with the test and results section. As you can see here, we have issued these scores, and which indicates that we have successfully developed a working model, and this is the model results. Now let's move on to our next test, the IMU filtering test, and this test was conducted during the free flights. The table on the right side shows the data before filtering, and as you can see, there is significant noise caused by the motors. And since the meaningful frequency of the drone movement is between 0 and 10 Hz, it is evident in the graph that once filtering is applied, the motor noise efficiently suppressed. And then on this slide about PID response test, looking at the graph, we can see that PID controller response is the opposite direction of the drone's movement, and behavior we referred as correction. Since there is no negligible delay, and we can say that the response is the desired level. Now, moving on to the altitude test, as you can see in the figure, the drone was able to reach the 15 meters without issue. However, due to the wind and weather conditions during the tests, we were never able to reach the exact target altitude we had originally planned.
Hello, I'm Furkan. This is one of our flight tests after tuning the PID parameters and optimizing the filters. In the next phase, we will also conduct tests of capture imagery of the coastal areas. Our commercialization plan is once standardized, the system will enter the policy inventory. In one package, we deliver real-time ship detection and counting, constant surveillance, and user-friendly GUI, and the modular and scalable architecture for Coast Guard units. Looking ahead, we aim for UAS certification under EASA or FFA regulation. We already built in a failsafe that shut down the motors on signal loss or removals, plus detailed flight log recording for post-flight analysis. Lastly, you can see the table details our cost through the project. We spent approximately 38,000 Turkish liras. Thank you for listening.